Okay, AQR, we are starting Unit 5. Here is Student Activity Sheet 1. So, one factor that talent scouts look for in potentially competitive swimmers is the ratio of their height to their arm span. For most people, arm span is generally equal to height. Consider, however, U.S. Olympic swimmer Michael Phelps, who is 6 feet 4 inches, 193 centimeters tall, with an arm span of 6 feet 7 inches, 200 centimeters. In fact, the U.S. swim team found that its male swimmers have an average height of 187.1 centimeters and an average arm span of 192.9 centimeters. Of course, other factors influence the success of a swimmer, but coaches often look at a swimmer's physical attributes, including arm span, to determine which strokes he or she should focus on. At a local competitive swim club, the coach measured the height and arm span of his top 10 swimmers. The data are shown in the table below. So we've got this data here. We're going to put this into the calculator. Number one, on the next page, we'll say, put this into your graphing calculator. So we're going to go to, have your calculator handy. If not, pause, go grab it. But on the calculator, we're going to go to Stat, right to the left of, just to the left of the arrows here, just below the Del button. So Stat, and then Enter. And I've already entered the numbers in. Make sure that you have the same number in L1 and L2. Okay, pause, put those in. Now, we're going to go, we have to turn on stat plot. If we want to look at the graph, we're going to go to second, y equals. You can see plot 1, plot 2, plot 3, they're all off. I'm going to turn plot 1 on, so I'm going to press enter. And notice on is highlighted. I'm going to press enter again. Now it is on. We're going to use that first type. X is my L1, Y is my L2. That's where I put my list, so that's all good. All right, now to see the graph, I'm going to hit zoom, and you can see number 9 under zoom is zoom stat. It's going to use what's in the statistics, which is exactly where we put this stuff into stat. So I'm going to hit zoom 9. And now, there is our scatter plot. Okay? So sketch that. All right? You can draw sketch the graph below on number 1. So sketch your scatter plot. Do that. All right, number 2, use what you know about the situation data to find a function model for this data set. Explain your reasoning. So we can do this by hand. Okay? If I look at the window here, I might just, if I do this, look at the graph. I'm going to kind of draw my graph. Okay, and then I go to my window and I can see where the edges of my graph are. So this is 170 for the X, goes up to 194, and it's about 169 for the Y, and it goes up to about 200, 199.9. So it's going about to 200. Okay, and what I want to do is I want to find a line. This looks pretty linear to me, at least. All right, this looks pretty linear, so I want to find the line that goes kind of through the middle of these. And I want that line to kind of be so that about half follow the general trend of the points, and about half the points should be above the line and about half the points be below the line. Okay, that's my idea. So I might choose, if I was just kind of looking at this, I'm thinking I can use trace here and kind of go point to point. So I'm thinking I wanted to go through that second point, 173, 175, and then maybe that point, 186, 189. So if I found the line, so finding a line that goes through 2 points. Haven't done this, you did this in Algebra 1, you did this maybe even in Algebra 2, but first thing I'm going to do is find my slope. Y1, X1, Y1, X2, Y2. I'm going to do Y2 minus Y1, 189 minus 175, divided by 186 minus 173. So this on top is 14, on the bottom I have 13. Now I'm going to say Y equals 14 thirteenths times X plus B. I'm going to plug one of these points in. It doesn't really matter which point I plug in, but I'm going to plug one. So I'm going to do 173, 175. So 175 equals 14 thirteenths times 173 plus B. So I'm going to go second mode. That'll take me to my home screen. I'm going to do 14 divided by 13 times 173. And I get 186.3. So 175 equals 186.3 plus B. If I do 175 minus 186.3, I get negative 11.3. So my equation is 14/13 x minus 11.3. That's the equation I got to go through my points. So what we're going to do is we'll end up seeing, I think, how accurate this is. Okay? So use your graphing calculator to compute a regression analysis. Sorry, you can't see that. A regression analysis of the swimmer's arm spans in relation to their height. What does the information from the calculator tell you? How does the equation given by the calculator compare to the function you found in question 2? All right. So first thing I'm going to do before we do all this is I'm going to turn on my R. Okay? So the way I do this is I'm going to, down here above 0 you see it says catalog. So I'm going to hit second catalog, and now I'm going to go to D. And to go straight to D, you can see right above the x negative 1 I have a little green D. So if I hit the x to the negative 1 button, it'll take me down to D. And I think I'm looking for diagnostic on. That's where I want, right there. See right there it says diagnostic on. I'm going to press enter. I'm going to press enter one more time. Done. Diagnostic is now on. All right, diagnostic is on. So when I do my regression, it's going to give me extra information because the diagnostic is on. So we're going to go to stat. I'm going to go to right arrow to the calculator and calculation here, and I want to do linreg, number 4, linreg AX plus B. So I'm going to say linreg. Before I do this, actually, we'll take out anything. If you have something in your y equals screen, let's clear that out. So let's try this one more time. Stat, right arrow, number 4. Okay, X list is L1, Y list L2, those are all good. I'm going to store my regression equation. So I'm going to hit second variables. Right below the arrows here is vars, that's variables. Sorry, not second variables, just variables. Sorry about that. Hit variables, hit the right arrow to go to Y variables, hit number 1 to go to function, and one more time hit number 1 to go to Y1. So now it'll store my equation into Y1. I'm going to go to calculate. All right, so notice it's giving me lots of information here. And I'm going to round it off a little bit. I'm going to say my equation is Y equals AX. My A is 1.02. Goodness, what should we round to? Let's call it round to 3 decimals. 1.022x minus 1.429. Okay, there's my equation. And notice the R value, R equals 0.963. All right, the closer that gets to 1, the more perfect a fit it is. So 0.96 is pretty good. It's pretty good. So let's look at the graph of it. If you look at y equals, you can see that it's already typed the equation in there. So I can just hit the graph button, and there we go. All right, so we have the line going through the points. Okay? Now, let's compare this to my equation. My equation, I had 14/13x minus 11.3. All right, y equals 14/13x minus 11.3. So if I do, I'm going to go second mode. If I do 14 divided by 13, I got 1.077. So this is approximately 1.077x minus 11.3. So then my slope's not too far off, really. In fact, it was pretty good. My slope was pretty good. My y-intercept's a little off, but you know, it's not too bad. It's not horribly long. But this is, you know, this is the best that we can do. I mean, this calculator came up with the best fit. We call that the line of best fit. Okay? So, all right. Now, this next part is group work. So, what I want you to do is I want you to do 2 of these. Okay? I want you to do 2 of these. And so why don't you do well, these don't take that long because most of your x values are pretty similar. So go on and do all 4 of these. Do all 4 of these. Sketch them out. What you're looking for is you're going to put. I'll do the first one with you. Okay, we'll do the first one together. So we're going to go to. Let's go to y equals. Let's clear this out. We'll say stat enter. I want to clear out what's in the list, and so I'm going to press the up arrow and clear, press enter, go over to L1, press the up arrow, I'm highlighting L1, press clear, enter. Don't hit delete. If you hit delete, you're going to delete the list. You don't want to do that. All right, so let's do the first one. I'm going to put into L1 -2, -1, 0, 1, and 2. And the next one I'm putting -4, -2, 0, 2, and 4. Okay? So, I'm going to do zoom 9. And there we go. We've got 5 points, our 5 points right there. All right, so let's just draw. We're going to draw a little sketch of that. So we've got 1, 2, 3. They're all in a line. We're going to do a regression equation on this. Stat, right arrow, number 4. We're going to store this line into, so I'm going to say vars, right arrow to y vars, number 1, and calculate. And notice my equation is y equals 2x plus 0, and my r is a perfect 1. So when I graph this, we'll see that the line goes exactly through every single point perfectly. This is a perfectly straight line, and my line goes right through them. Okay? So when r equals 1, you get perfect lines. You have a perfect line, and the equation goes right through it. All right? So graph the others of these, draw your little sketches, figure out the r values, and when you've done that, after you've done that, you should be able to answer number 5. This is just matching. All right? We're matching graphs with the r values, and so see if you can figure out which graphs go with which r values. All right? And so we're going to put this on the evaluation. I'm going to have 1, 2, and 3. We're going to have A, B, and C, and we'll see how that works out. Okay? Then, number 6 says, does a strong correlation indicate a cause and effect relationship between variables? All right? So think about that. Think about that. Does a strong correlation indicate a cause and effect relationship between variables? Give examples to justify your response. So think about that and answer that, and we will. And also, also think about number 7. Think of a situation that might have a linear relationship. Research, well, you don't have to research it, but just think about, things that have linear relationships. Okay? All right, that's it for today. Hope y'all are doing well, and I will talk to you tomorrow. Bye-bye.